main page पे आइए, लेफ्ट साइड पे।
ग्रीन हो जाएगा चल लाइट
ग्रीन हो जाओ भाई। Okay, so we are back again, and again, sorry for the inconvenience caused. Am I audible to all? You can just type in yes or no so that I can start my training. Am I audible to all? Okay, so as I have got the confirmation, and I'm going to start it again, right? So I started with what are asteroids, and now I am going to continue that thing only, right? So I had already covered till what are asteroids and who discovered them. So in 1801, as I said, Giuseppe Piazzi, he discovered them. Now I want to tell you about the types of asteroids or what asteroids are made up of. So whatever material which is there inside the asteroid or what asteroid is consist of depends on how far away they are formed away from the sun, right? So we have three types of asteroids. One is a C type, second is S type, and third is M type. C type chondrite asteroids, which are the most common ones. Then we have stony asteroids, and then we have metallic one, right? Now moving ahead, so how big is an asteroid? So here I have an image to compare the size of the biggest asteroid that we have, that is Ceres, which is also a dwarf planet, right? So let's compare it with the Earth. So if I say, if I talk about the diameter of Earth, then it is nearly 12,800, and then we have Moon, that is actually 1/4, and that is 3,400 something, and then we have Ceres, around diameter of 950 kilometers. So you can think of the largest known asteroid that we have is having a diameter of around 950 kilometers. So you can think of how big it is, right? And do you know how small they can be? So they can be of few meters, right? On like on the smallest size, they can be of few meters. Let's say 1 meter, 2 meter, something like that, right? So diameter of about 1,000 kilometer and down to the size of pebbles, right? So what is the number that how many asteroids are bigger than let's say 200 kilometers, something like that? So we have nearly 15, 16 asteroids with a diameter of around 250 kilometers or more. Just like if I talk about different asteroids, so we have one asteroid Gaspara, which is an S-type asteroid, and it is believed to be composed of a mixture of rock and metallic minerals. Then we have another asteroid, Ductile, right, which is having a size of nearly 90 kilometers, right, and it is actually the moon of another asteroid known as Ida, right. Next, I have one more asteroid that is Mathilde, right, and it's a part of main asteroid belt, right, and it's like a loose rubber pile with a density of water, right. And then at last we have one more asteroid, Eros, which is an S-type asteroid, and it was the main target of the near mission, right. So, where exactly are asteroids located? So, on the right side of the screen, you can get an idea. So, all these red, blue, green dots are just the asteroids, right? So, nearly there are actually three locations where we can find out asteroids majorly. First one, as we all know, that is main belt asteroid or MBA between Mars and Jupiter. Second one are near Earth asteroids. So which are like let's say which are near to our planet Earth and they're within the orbits of Mars. Right. Again, the third one are the Trojans, which are in the orbit of Jupiter. You can see two group of blue dots right in the orbit in the outermost circle. So those are actually your Trojans. Right. Now moving ahead and let's talk about them one by one. That for which asteroid we are actually doing a train. Now types of asteroid, as I said, first one main belt asteroid. So orbit between the planets of Mars and Jupiter. So there's a whole complete asteroid belt where they lie in millions in number, right? Next we have near Earth asteroid, right? So that the orbit lies very near to the orbit of the Earth, right? So if I go by numbers, then the orbit is let's say in 1.3 AU from the Sun, right? If you will calculate it mathematically, then 1 AU is nearly 150 million kilometers, right? And if you'll further divide it, then it's say near around 200 million kilometers from the Sun. We are having some asteroids, and these asteroids are the actual threat that we are looking for, right? Now this is the edge on view, right? So if we see all the near Earth asteroid, then this is an edge on view. So in the center of this picture you can see a green line that is going to be the orbit of Earth. The bright dot is the Sun, and these all blue orange dots are just the asteroid. Now you might be getting an idea that where we are actually living in between the rods, right? And categorization of NE. So NEAs are further categorized into three categories. Now one is Amor, which are not actually very dangerous for us, right? We are less concerned about them. Then we have Apollo, and then we have Aten, right? So what are these three types of asteroids? So here in the picture, the orbit is shown, right? And in the center we have Sun, and the orbit marked with E is the orbit of Earth. So you can get an idea that which all asteroids are going around the Earth, whether they're Aten, Apollo, or Amor, right? Let's talk about them one by one. So first one in this case is the Aten. So their orbit actually crosses inside the Earth orbit, means maximum part of their orbit, these Aten asteroid orbit, is within the Earth's orbit, and they are the major problem for us, right? These are the asteroids that we are majorly looking for. And the very famous example is, like, you might have also heard that there's an asteroid that we have predicted will impact Earth in 2029, right? Let's say 10 years after, right? So name is written here, 99942 Apophis, right? So talking technically, what is their distance? So their aphelion, right, is greater than 0.983 AU, means on their from the Sun, their distance is greater than 0.9 AU. But the semi-major axis, on their axis, right, the distance is less than 1 AU. So 1 AU is actually the distance of Earth. So you can think of how near they are to our planet Earth, right? And that the same thing you can see from this orbital diagram also, right? Like where two orbits are shown. So the blue orbit is the orbit of Earth, and the orbit shown in the purple is the orbit of the Atens, right? So here you can see their distance. Now let's move on to the second one. Second one are Apollo asteroids, right? So their orbit, it crosses inside of Earth's orbit. They can potential threat of collision, right? Their semi-major axis greater than that of Earth, but perihelion distance is less than Earth's aphelion distance. Like in the very simple language, if you go by the orbital diagram, right? So the green orbit shows that how near they are to Earth. You can see near about the Earth's orbit, some part of this Apollo asteroids are there, and the potential they are the major candidates for the collision with the Earth, right? Although the number is less, right? Next The famous example of this is Chelyabinsk meteor. Like if any one of you know about this, then there was one tragedy in Russia in 2013, right? So that is known as Chelyabinsk tragedy, right? So that was because of one of the Apollo asteroids, right? Now the third type of asteroid that we have are Amur asteroids, right? They do not cross the Earth's orbit and they do not cross the Mars orbits as well. So, in short, they are in between the orbits of Earth and the Mars, right? And they are not, as such, they are not dangerous until or unless something collides with them and they come near our planet Earth, right? The famous example of this is 433 Eros, right? Again, it's one Eros is a very famous asteroid. We have sent a mission to it, right? Now, significant dates. So if I put on all the things, like all the missions, all the studies that scientists and the humans have conducted for the asteroids, right? So significant date wise, like there's a simple timeline for this, right? So this all started from 1800 when in 1801 Giuseppe Piazzi discovered the first and the largest asteroid, that is Ceres. Then in 1898, let's say 97 years after, there was another person, Gutzowitz. He discovered Eros, that is the largest, one of the largest near-Earth asteroids, right? And then in 1990s, the Galileo spacecraft took the first close-up image of another asteroid that is called Caspera, and discovered that asteroids can also have moon, right? So there's an asteroid Ida, and it is having a moon known as Dictite, which is orbiting that particular asteroid. Then 10 years later, let's say near about 2000, the Near Shoemaker spacecraft flies by another asteroid that is called Mathilde, and it landed on Eros, right? In between that year, like 1997 and 2000, NASA establishes a program that is called Near Earth Object Program. So their main aim at that time was to detect, track, and characterize the potentially hazardous objects that can approach Earth and can cause devastation, right? So the main aim was that, right? Next, in 2006, Japan sent an spacecraft that is Hayabusa, and it became the first spacecraft to land on an asteroid and to collect sample from there, right? And in the same year, Ceres attained a new classification. Now it is more famous as a dwarf planet, but it retains a distinction as the largest known asteroid. In 2007, Dawn spacecraft was launched to its journey to study the major asteroids of the asteroid belt, that is Ceres, and the second largest asteroid, that is Vesta. Right? In 2008, another European spacecraft, Rosetta, on its way, study like it flight by to an asteroid named as Thames, right? And it is a type of asteroid which is composed of some silicates and basalts, right? In 2010, Japan's Hayabusa mission returns its sample, right? And the same year, the Rosetta mission, it flies by to another asteroid, that is Lutetia, right? And that is it revealed that a primitive survivor from the violent birth of that Lutetia is a survivor from the birth of our solar system, right? So the timeline goes on, and now what we are going to do. So recently, one mission, that is Osiris Rex, was sent, right? And currently it is orbiting the asteroid Bennu, and has achieved a feat that it has observed that particular asteroid from the nearest possible distance, right? Like it has gone as near as 68 meters, right? So this was all about the asteroid. Now we'll talk about a program, right? A program AIASC, that what we are going to do in that program. So I'll start off with another presentation, and Okay, so let's start with the second presentation. Like, what does actually what AIAC is all about, and what is your role in detecting the asteroid? What are asteroid we are going to track? So, in my first presentation, I covered about the types of asteroid, and our main target are the near Earth asteroids. I hope now, till now, everything is clear. And if you want to know anything more, you can just type down your queries over here on the YouTube channel, and I'll revert back later on. Right? Okay. Now, moving ahead. So, in All India Asteroid Search Campaign, we started this campaign in 2010 with an idea to bring this opportunity of hunting the asteroid to the students. Right now, before that, like the scientists and the elder people used to do it, but in 2010, with an idea to bring the program on the students level and to help the humankind in searching for these potentially hazardous objects, we came with All India Asteroid Search Campaign in collaboration with International Astronomical Search Collaboration, that is IASC. So, welcome to the phase one of the IASC, and let's talk about the overall thing that what we are going to do. So, the basic flow structure of AIAC would be that is we will be providing you with some data, that data that we'll be getting from the IASC. Then what you have to do, you have to download that data from our website, and you have to analyze the data using a particular software, that is astrometrica, and then you have to report the moving objects in that, right? And at last you have to send that report, right? So we'll cover up all these things, that from where to download the data from, like how to use the astrometrica software, how to create the report in the second and the third section, right? So let's start. So the first thing, like data downloaded on, but before data. Okay, so before downloading the data and all, or before directly moving to the astrometric software, it's very important to understand the concept, that what concept we are going to use in that astrometrica software, right? So I'm going to start from this. So we have already talked about the asteroids, right? And these are the NEAs and different types of asteroid that we have. So all the like as you can see, we have an asteroid belt over here, and see there's an animation. So here, this all these white dots, if I have to tell you what are these, then these are the near Earth asteroids, or the space rock that are going around our planet Earth. And in 2016 this map was updated, and this is the data, right? So as you can see here, can you like here in this, that blue circle, that's the orbit of our planet Earth, and we are actually living in between the rocks, right? So all these white dots over here in this picture are the near Earth objects that can be anytime, they can cause devastation over here. So what they have done till now, as I told you, one Chelyabinsk event was there, and here's a video of that Chelyabinsk event. So like there was an space rock which exploded in the mid-air, and the effect was seen everywhere. Means the shock wave was this explosion took place at an altitude of some 27 kilometers from the ground level, but all the glass panes in that area, they got cracked, right? So its shock wave was felt everywhere in that area, and huge devastation was there in that area. A similar kind of event happened some 65 million years ago, right? So that led to the extinction of dinosaur, right? So here you can see a buried crater, that is Chicxulub crater, right? And this is nearly 500 kilometers in diameter. Half of them it is an ocean right now, right? So that it led to the extinction of the dinosaur, right? So this year, as I said, is the 10th year of All India Asteroid Search Campaign, and from 2010 we are conducting this in collaboration with IASC, right? So here is the Professor Patrick Miller, who is director of IASC, and till now, like in last 9 successful years, what we have achieved. So till now we have got one numbered asteroid, we have got 56 provisional discoveries of asteroid, we have got 2 special discoveries, and till now there have been more than 4,300 preliminary discoveries, right? And we have got 62 NU confirmations and 1636 near Earth object observations. So what are these terms, number, asteroid and all? I'll cover it later, but as of now these are our achievements. So you can think of what platform that students have got, right? Now how, from where we are getting this data, so how we are taking up this data. So this, we are getting this data, or IASC is getting this data from the Pan-STARRS observatory, right? So there are 2 telescopes over there. So we are taking the data right now from the PS1 telescope, which is having a 1.8 meter primary mirror. It scans one particular area of the sky and takes 4 images at a time, right? At a time means it, at the interval of every 15 minutes it takes a set of images, right? And that set of image consists of 4 images, right? Now what happens during the entire program? So PS1 telescope takes the images of the night sky, then images are processed and are made available to students or to the participants of AIASC. Then students have to download the image data to analyze it with the software astrometric, and they have to find the moving objects, and then the students have to send a report based on their analysis. So what are steps I said we'll talk about. So these are all the steps, and then the process of discovery, how it goes. So let's say you report an object, then IAC declares that discovery of any new asteroid, we consider it as preliminary. It is not a confirmed discovery. So let's say you report an object and it is you get a message that congratulations, there's a preliminary discovery for you, then don't consider it as a confirmed discovery, right? Then Pan-STARRS have to take a follow-up of that image, right? Now once you get the follow-up, right, so in case the image is taken from the Pan-STARRS telescope again, then MPC, that is called Minor Planet Catalog, it officially recognizes the discovery as the provisional one, that is called a confirmed discovery, and give it a temporary designation, right? Or in case, let's say that asteroid, we never find it again, or in case it was not an asteroid, you report just an anomaly as an asteroid, then in that case the image will not be taken again and it will remain as a preliminary discovery only, right? Now once it becomes a provisional discovery, then let's say one of you have observed that object. Now let's say there's another student who scans the same part of the sky and he also gets that same object. Now that becomes the second observation of that particular asteroid. So then it is known as a near Earth object confirmation, right? The second observation for that particular object, and the third and the fourth observation of that particular asteroid will be considered as near Earth observation. Now it can be anyone who is making that confirmation and NEO observation, but it is a provisional discovery for you, right? Now after this, why we observe it for such a long year? Because there is a laboratory, it's a part of NASA, that is Jet Propulsion Laboratory, right? They use this data, right, confirmed and observation asteroids, right, to update the NEO database, that is Near Earth Object Database, the same database from where we got that image of that video, right? So showing a lot and a lot of NEOs around the planet Earth, right? Now what is the now provisional to numbered asteroid discovery. So temporary designation is given to a provisional asteroid by MPC, right? Then once the reliable orbit of that asteroid is calculated, now it is known as numbered asteroid discovery with a permanent designation given by MPC. So here comes your chance to give it a name, right? So it takes some time. Now what is that time? The time is of minimum 6 years to calculate the orbit of an asteroid. So now let's say today you discover an asteroid and you get a news that it's a preliminary discovery. So you have to wait for to get it to be marked it as provisional asteroid, right, by MPC. Then to name it, it will require at least 6 years, right? And that's the minimum time that they need to calculate the orbit of that particular asteroid. Then only you will be getting a chance to name it, right? Next, so what technique that they use? So to explain you the technique, right, here I am having two images. Now I want to ask you one very simple question. Can you see any differences in these two images? I'll take a pause here, pause of 1 minute, and you just comment down whether can you see any differences in these two pictures or not. So you just comment yes or no. If there's any difference, let me know yes. If there's no difference, just let me know no, so that I can move forward. Okay, now to tell you, like, these two images are looking very similar to each other. I got few answers. Right now these two images are looking very similar to each other. Now how can I find out the differences? So here I am going to use a trick. I'm going to take both the pictures in a single frame, right, and I am going to blink them to see the differences. So here I'm having the first image and here I'm having the second image. So as I blink the two images, you can see the difference in them, right? So there are a lot of differences in the two pictures, right? And the same technique we will use to find the moving objects in such a huge data that we'll be getting from the PS1 telescope, in the images that we'll be getting from the sky. Now how we are able to use this technique? So if I have to tell you the concept, then it's as simple as, let's say we are observing the night sky from the telescope, right? Now that particular telescope is actually tracking the sky. Now let's say I take my first image, right, and in that first image it will capture some stars, and let's suppose there's one asteroid in there, right? Now the second image, as it is tracking the sky, so in the second image, in the first and the second image, the stars will appear to be stationary, but asteroid, as they are very near to our planet Earth, they will start appearing moving, right? They'll move as compared to the first frame, right? Why they'll appear to move? Because they are very near to our planet Earth, so apparently their position will appear to get changed in the second frame, right? That's taken after 15 minutes. Now let's in the third image, what will happen in the third image? Again, as the telescope is tracking the sky, so stars will remain at their position, but asteroid, with reference to the other stars, it will change its position, right? So this is the technique that we are going to use. Now here I am having one photograph on my screen, and here you can see one of the object on the screen which is marked as asteroid 2010 PO24. That's the one numbered asteroid that students have found, right, from who were the part of the AIASC. Right. Now here you can see how faint they will look like with reference to the background image, how the asteroids will move. So this is how you will spot an asteroid while blinking the four images. It will look, the four images, the blinking of four images will look something like this. Now the asteroid that you are going to find are these faint targets, right? So you have to be very careful while doing this blinking and all, right? Now the organization, space is the organization behind the 9 years of successful asteroid discoveries in India, right? Why? Because we conduct specialized workshop and train students on astrometric, and we provide 24 into 7 technical support throughout the campaign, by call, by our emails, right? You can hang out us, right, with our ID that you have got, right? And we also felicitate the asteroid discoverers, right? Now AIC 29, as we know, it is going to be conducted in two phases. Phase 1, which is going to start within a few days, right? And phase 2 will start in July, right? And we also got the media coverage for the same, right? And asteroid discoverers, they have got a lot of popularity after discovering the asteroid through a program. They have been interviewed, they have it has helped them in their internship and their higher studies a lot, right? And discoverers were congratulated by the ministers also. So they get lot and lot of fame once they get a discovery, right? So this is all the media coverage that we have got, right? Just a part of that. Now the two students here in the middle, like starting from the left, the third and the fourth one are the numbered asteroid discoverers, right? And so who all wants to discover an asteroid? So I hope you all want to discover an asteroid, and that's why you have joined this campaign, right? AASC. So for any questions, if you have any questions, you can just type down your questions, I'll answer them later. And now I am going to start with the process of AIASC, right? So for the process of AIASC, few things that I want to let you know beforehand, right? So those few things are, first thing, you should have an active internet connection and it should have good speed. That's the first and the foremost thing that is required for this, right? So now the software the software that we are going to use for this is Astrometrica. Now how you all will be getting the software and the dataset, right? So first of all, as I said, like you will download the data from the space website. The step 1 is written over here, right? Now from where you are going to download the data, so I'll be going to the space website now from here, right? So on the space website, right, as you'll open the space website, that is www.space-india.com. so that's a website, right? And once you go on the website, you have to go on the section what we offer, then go to the section of outreach, and in the section of outreach, go to associated members program, that is All India Asteroid Search Campaign, and this page will open up, right? So here you'll scroll down, you'll get an overview of our program, and there are different tabs, right? So first of all, the first thing that you have to do is, let's say you want to download your data. So once the campaign will start, right, you will go on this place, that is dataset, and here right now, as you can see, the school's name, so your team name will appear here, right? Let me be very clear, right now there is no data on this, right? So this is the AIC 2018 data of phase 2, and 2019 phase 1 data will come only once the campaign will be started, right? So once the campaign will start, you'll get your team's name folder here on the website, and in the same folder you will be getting your data. So let's say if I open up any folder, it will redirect you to one of the page, right? And that page is of IASC, right? So it will direct you to the page of your data sets, right? Now I'm moving back to the presentation, right? So first step is clear. I hope the first step is clear how to download the data. Now, second thing is unzip the data and save it with the same name. Now, a suggestion, when you are going to use the astrometrica, right? So keep all the data on your desktop or keep it in the same drive. Your software and all your data, keep it in the same drive. I don't use any external drives for it. Let's say you download an software in your laptop and then you're going to take the data from any external drive, it will show you an error, right? So for the safe side, what you have to do is, first thing, you should have internet. Second thing, keep the data in the same drive, right? And if possible, keep it on the same location, right? Now unzip the data, because the data that you will be getting are the WinRAR files, right? So some files like this, right? So here are some unzip files, right? So there are some files, there's some zip files, right? What you have to do is to open this data, you have to extract them, right? So here I'm having a small video that how to download the data, and second thing, how to see, first video is of how to download it. So as I said, on our website, you have to go to the column of dataset, and there you can download your data from your school's folder, right? As I said, it will direct you to that IASC page, and there it will require a username and password. That username and password you will get once the phase will start from IASC. You have to log in over there, and your data will be there in these like this. So here you can see the data sets, right? The data set name will, let's say it starts from PS1, right? When you click on it, your data set will download, right? And it's a RAR file. As I said, it's a compressed file. You have to unzip it for using. So here is a data file. Extract it. As I said, try to keep all the things on your desktop or in the same drive where you're having your software. So here my software is on the desktop, so I'm going to keep it on the desktop only. Okay, now step number 2 is like points to note in this. So each school will be getting its own image set to analyze, or each school or each group. It's very important that you do not analyze the data sets in other school folder. If you will do that, even if you discover an asteroid, you will not be getting the credit for it, right? The other two students, they will get the credit for it, right? So there's no use for analyzing other schools data. Right now the image sets are uploaded in order, right? Let's say first, let's say if they have 40 data sets, so they'll pick up 10 schools and they'll upload the images. Right now at a time you can get 4 data set, 3 data set, 5 data set. It can vary, right? And if your school currently it has not got any image set to analyze, but if you can see that other schools have got it, so be patient, right? You can be next in the line, right? And if you do not participate for a very long time, right, your data will be diverted to other schools folder. So this simply means your chance of discovery will be given to someone else, right? So we suggest that try to use the data and analyze it as soon as you get it from the website, right? Next, how to analyze the data, right? So for this, you have to install the software Astrometrica. Now this video is showing you the installation process of Astrometrica software, right? So this Astrometrica setup you can download from the space ID also, right? So over here, let's say if I have to tell you that from where you can download the software, go on the same website AIASC and go on AIASC CD. So here you'll be getting Astrometrica software. So click on the first thing, software setup. You will get the setup folder, right? And along with that PS1 configuration, again it's a RAR file, you have to extract it, and as I said, install it on the desktop only, right? So I am going to play that video how to install that software, right? So let's say this is my folder, right? I have to go in the setup file and I'll click on that Astrometrica setup, click on yes, right? And then Astrometrica installation, next, and next. A simple step for the installation, right? And please be very patient and keep your please be with good internet speed while you are downloading Astrometrica, right? Now once the download is complete, right, open the Astrometrica from the desktop. For the first time, open it from the desktop, right? Now how it is going to help you out, it will update the database for you. Now if this database will be there, if this database is updated at the time of installation, that means half of your work is done. If it is not done at the time of installation, believe me guys, you are going to face a lot of problem because of this, right? So first thing, install the Astrometrica. Second thing, for the first time users, kindly open the Astrometrica from the desktop so that it can update the MP-COP database. It's the same database where it is having the data of the moving objects, right? And it needs, again and again I'm repeating, it needs good internet connection, right? So it will take some time for update, let's say 5 minutes, 10 minutes, 10 minutes, depending upon your internet speed, right? And once this thing is done, over here you can see the progress, right? So I'll skip this part of installation and it will go till 100%. Now my MP-COP database is updated and read the data from MP-COP database. Now if you get any sort of error, so possible errors during this installation is, you install the Astrometrica, you open it from desktop, but let's say your internet speed is not good, it will show you an error, MP-COP database not found, right? Second error that you will get or you might get is, you install this Astrometrica and let's say it will skip that part, it will skip that warning, right? But you'll get this error of MP-COP not found once you will analyze the data, right? So updating that MP-COP database is very, very, very important, right? Now install Astrometrica software installation is done. Now Astrometrica software registration, right? So the key, the license key and the password for the Astrometrica software registration will share you with the email, right? Right now the key will be there, but I'll skip that part, right? So the key will share with you on the email. Now practice dataset, how to use that practice dataset, right? So over here it's written copy from CD and extract it. Now you're not going to copy it for sure, you have already downloaded, like you have to download it from the space website, the practice data sets, right? So how you are going to download that? So you have to go on our website, and on the same column, astrometrica software, the first thing that you will get is a software setup. Second thing, the second thing is the support document, and third thing is the practice data. So once you'll click on this practice data file, right? So on this practice data file, there, like once you click on this, some 8 or like it will bring you to the to a folder in the Google Drive, and here you can find some 8 or 9 practice data sets, right? So you can download them, and you can download all of them, right? And you have to extract it, and you have to analyze these data sets, right, to practice the astrometrica, right? So let's move back to presentation, right? Now next step, once you get the data or once you install the astrometrica, right, in your astrometrica there are few things that you have to take care of while using it. So over here on my screen, the astrometrica interface is there. Now over here on this corner, right, where I have taken the cursor, it's written ARI24.cfg. So this is the configuration that we are going to use for astrometrica, but ARI24 is not the right configuration that we are going to use. The configuration that we have to use over here is the PS1 configuration. And second thing that we have to change on the astrometric interface is this PPMXL, right? So this PPMXL is the star catalog. Now when you will install the astrometrica, by default, either you can get PPMXL over here, or you can get UCAC4 over here, right? If you're getting anything, so how to change these two things, I'm going to take you to the interface of astrometrica, right? So right now, as I have opened it from the desktop, it will take time, right? So to avoid this thing, what I can do is I can simply open the astrometrica from my C drive, right? So I have to go on my computer and local disk C. So there, here I have the folder of astrometrica. I can open it directly from here. So as my mpcop database is updated, right, I can open it from the C drive, right? And here, first thing that it is going to do is to read MPC of database. Now, if it will show you a warning when you started, mpc report.txt and astrometric.log already exists, replace the existing file, say yes. Right now here in the corner you can see ppmxl. So when you install it for the first time, it can show you either ppmxl or ucac4 or something else, right? So if it is showing you anything other than ppmxl, then you have to change this star catalog. So this is actually star catalog. Then over here, the configuration ps1, we have to change this configuration if it is anything other than that ps1. So how to change this ppmxl star catalog? So you have to go on this icon, this program settings icon, click on it, go on the option of program, right? So third option is the option of program, right? Here you will see an option of star catalog. Click on this, there's a drop down menu. Here you will see different star catalogs. So we have to work with ppmxl. Now anything other than ppmxl, if you use, you will not be able to move further in this astrometrica software, right? So once it is done, press OK. Now to change this configuration, if it is anything other than ps1, so one thing, like the configuration file, where you will be getting the configuration file, one, in the folder from where you will download the setup. Second, if you will go on, you have to go on program, and then there's an option open. Click on open, then go to the folder of astrometrica, right? Let's say in my computer I have I'll go on C drive. On the folder of astrometric, I will be having a folder known as settings. So go on that settings folder. Here you can find out that PS1 configuration is there. Click on that PS1 configuration and open, right, and press OK. Now my astrometrica is ready to work. Right, now next step is I have to load the image files in this, right? So, and to analyze the data, right, we have to use this astrometrica software. Now here I need my data sets, right? So I am going to take out let's say I take out this data set 203. I'll extract it. Right, now once I extract it, I got this folder 203 over here, right? And now in this folder there are 4 images with an extension .fits. So you cannot open these images with a normal image viewer. Right, now over here I am going to open this data. Right, how to open this data? I'll go on file, I have to load the images, right? So I'll check for this directory over here. And here I have my 4 images. I'll select all of them by pressing Ctrl A and open. Now at this stage, so while I'm opening these images, right, they opened up smoothly. Right, now if there is any error in your astrometrica software, right, so how you can check whether your astrometrica software is perfectly installed or not? At the first step, at this step only, right, you will get a dialog box, right, after opening the every image. Right, let's say I open the first image, then you will be getting a dialog box to press OK. Then there will be you open the second image will be opened automatically, right? Then again you will be getting a dialog box. So that is actually an error. So at the same time, what you can do is you can just close off this astrometrica, right, and reinstall it again. Right, uninstall all the components of astrometrica from your system, right, and reinstall the astrometrica at the same moment. Right, next, now once your data is uploaded, now there are 3 controls on which we have to work to search for asteroid. Right, now the first control is, so here on the screen all the data which is already given in the MPC database, so that we can have an idea that what all stars are there. So the first step is of astrometric data reduction. Right, so we are going to reduce our data, means we are going to compare it with the standard data, that what all stars are there in this and all. Right, so first thing that you have to do after opening the image set is astrometric data reduction. So here you can see the screen icon, right? So there's a crosswire like thing, and click on this. So it will ask for this, right? There is a table will open where you have to enter objects and all. Right, so don't enter anything into this, just press OK. Right, now extracting objects. Now and this thing, so if your MPC of database is updated, everything is going fine, it will extract the object and it will show you one table of results. And if your internet is not working, or if any other error is there, you will find some you can find some error message over here. Right, so if you find let's say any error, the most common error in this is reference star match error. Right, so if you find any sort of error, just take a screenshot and send the mail to us. Right, now here you can see the data reduction results. Right, so it means our astrometrica is working fine, right, and our data is reduced. Now the second step, I can move forward, and the second step is right over here, that is known as known object overlay. Right, so let's say you have some data, right, and in that data you find a moving object, but that moving object has been already reported by someone. Right, so there is no use for finding that. Right, so it's better to keep a marker on that. Right, so that we can identify beforehand that what all objects are already marked. So I'll click on this, right? So once I click on this option, what it will do, it will show us all the objects which are already marked by MPC, right? So it will show some designation, some number over there, right? So it is going to select all those objects, and once the process is complete, you can see here on my screen a number. So it means there is already an object which has been numbered by MPC, right? So even if we mark this particular moving object, then we are not going to get any credit for this, right? So we can avoid this thing, right? And the third and the most important option, now we have to blink all 4 images. So here you can see the option of blinking, right? So you have to click on this and a new window will open which will show you the blinking of all the 4 images, right? So here you can see the sky moving. Now here on the first side you cannot see any asteroid moving, then don't get disheartened. See, actually these are different areas which you have to scan, right? Now on the first side, if you're not getting any moving object, don't worry, take your time. You have to be very patient while doing data reduction, right? So first thing, zoom in, right? So that you can get a better view of the same window which you are going to analyze, right? So one by one you can check for all the windows. So let's say I have zoomed in and I can see here in the first window there's nothing as such major moving object is not there, right? In the second window, and I'll scan the whole data set, right? So once I scan this over here in this window, I can find something, right? So I'll go on that particular window. See here, now here is one black dot which is moving very fast, which is changing its position rapidly with respect to the other stars, right? So this can be a probable candidate for an asteroid, right? This black dot which is moving, which is changing its position with respect to the other stars in all 4 images, right? So this is an asteroid, right? And this is what you have to find, right? Now this asteroid over here, right, is a very bright asteroid, and that's why it is that much black, right? You can have some very faint targets, right? So you should find them as well, right? Because it might be possible the bright moving object, it is an asteroid, but it might have already been discovered by someone, right? So you have to search for all the moving objects in a particular data set. Don't leave anything which is moving. Please don't leave them, right? Report them. It can be a probable candidate for asteroid, right? So one, again there's another one, right? Two, so 2 asteroids are there in this, right? And see, this is a practice data set, right? So you have to search for these kind of objects in the actual data sets, right? Now our next step, once we get these 2 asteroids, our next step is to report them. But can we report any moving object as an asteroid? The answer is no, right? A big no. Why? Because it can be a anomaly as well, right? It can be something, let's say a satellite is going, or let's say any other space rock is there. Let's say it's just a noise in this picture, right? Anything which is moving, we cannot report it as an asteroid. So what is the criteria, right? What is the criteria to report an object as an asteroid, right? So there are 5 points that you have to take care of while reporting anything as an asteroid, right? So now we are moving on the next step, and the next step is how to report an asteroid, right? And what is the criteria to report a moving object as an asteroid. So now I'm going to take this asteroid, right? So I hope till now the process is clear, right? Okay. Now, to report any object, right? So first of all, you have to stop this blinking screen. So here you have 4 controls, right? So stop the blinking, right, by pressing on the red button, and just find out your target which you are going to report. Now bring the cursor on that and put the cursor on the center, click on it, right, and the window will open, an object verification window will open, right? Now the first thing that you have to check for to mark any object as an asteroid is it should move in a straight line, right? If it is taking any curved path or any other path apart from a straight line, don't report it as an asteroid. Discard it in the first one. Now, as my moving object passes this test of traveling on a straight line, I have clicked on it, right, and I have to check other parameters of it, right? Now, what are other parameters? So once I click on this, right, object verification window will open, right, and here you can see one graph, right? So this graph, this Gaussian curve actually represents the data points, right? And this is actually the graph of its brightness, right? Now all these white data points should lie along the Gaussian curve, right? So if it is lying along the Gaussian curve, then only we can report it as an asteroid, right? This is a second check, right? So let's say if I click on anything else, this Gaussian curve will be different. See this object, for this the Gaussian curve is very much scattered, right? So we cannot report it. Let's say if I take some other object, let's say from here, right, see the Gaussian curve, it is not even, the curve is not even Gaussian, right, and data points are scattered, so we cannot report this object. So I'll come on my object, right, and see the Gaussian curve, all the data points are also lying along it, right? So I can report it. 2 points are clear. The third point on that we have to check is its SNR value, that is signal to noise ratio, right? How much signal we are getting from that particular asteroid. So this value should be greater than 5 always, right? If this value is less than 5, and even if it is let's say it is 2 or 3, right, and it is fitting on that Gaussian curve, then there can be a probability that it is some anomaly or it is just a noise, right? So you have to check for SNR, and it should always be greater than 5. So in this case it is 17. Next, 3 things are done. Fourth one is its magnitude, right? So here this alphabet R represents the magnitude, right? So in some of the some of you can get this R, in place of R you can get V, right? So don't worry, that V also represents the magnitude, right? So this magnitude you have to check, and in all 4 images the fluctuation of this magnitude should only be of plus minus 1, right? And if it is fluctuating more than 1, then don't report it as an asteroid, right? In all the 4 images it should vary at maximum by 1. So let's say in my first image, right, it is its magnitude is 19. So in all the 4 images it can go either up to 20 or up to 18, like it can be between 18 to 19 or 19 to 20, right? So if it is coming in that range, then only I can report it as an asteroid. Now the fifth condition for this is very simple. The condition is your moving object should appear in at least 3 of the images, right? Out of 3 images it should out of 4 images it should appear at least 3, right? Why I'm saying at least 3? Because in some cases it might be possible that there's a moving object and it is visible in 2 images, and there's no sign of it in other 2 images, right? Then most probably it is not an asteroid, it's a noise, right? It might be possible that in some of the cases that there are 4 images, but instead of coming like this, First image can be here, second can be here, third one is going behind these gray lines, right? And in the fourth image, the asteroid is again coming out, right? So in that case, you can report it. So I hope all the 5 conditions are clear. First condition, it should move in the straight line. The second condition, its data point should lie on the Gaussian curve. Third condition is SNR should be more than 5. Fourth condition is its magnitude. It should fluctuate only by plus and minus 1, right? And the fifth condition, it should be visible in at least 3 images. If you get all these 5 conditions, then only you can report an object as an asteroid, right? Okay, we can do a small trade-off over here. What is that trade-off? The trade-off is of SNR. Let's say 4 conditions are clear and your SNR is coming up to 4.5 only, right? Or let's say 4, right? Then also you can report that moving object as an asteroid. Now, how to report it? So my object I have selected, right? And here in the object designation, you have to give a temporary designation to it, right? Now there is a particular format for giving designation to the objects, and that format is 3 alphabets and 4 numbers. I repeat, that is 3 alphabets and 4 numerals, right? It can be anything. So let's say as my name is Yogesh, so I'll write it down YKJ, and I write my number 4 times 0. So this is my object designation, and I'll press accept, right? So here you can see the name that you have given, YKJ000, or the object designation that you are going to give will come just above this asteroid, right? Now let's suppose you are not getting this marking, right? You have given the object designation, everything you have done, and you are not getting these markings. So what in that case, what you are going to do is just right click on this, and here in this window, you'll be getting all the options. You can click on select markings, right? And mark all the checkboxes, right? Basically you have to mark that moving objects, right? Known objects and all, right? In case of blinking, mark all the 3 and press OK, right? Then you can see that name, right? Next step is you have to take care of one thing, that you have to give designation to this moving object in every image in which it is visible, right? So as it is visible in all 4 images, so here on my blinking window only, I'll move on to the second image, right? So right now this is image 4, right? I'll go to image 1, right? So this is my moving object. I'll click in the center of it, right? And again, one thing is, because this is the same object which is going in a straight line, so I'll give the same name to it, right? In all the 4 images. So in image 1 it is done, in image 4 it is done, image 2 I'll again click in the center of the object, right? So why I'm clicking in the center of the object? Because if you click on any other side, let's say on the sides of this, right, your Gaussian curve will be distorted, right? So always click on the center, try to click on the center of the object, right? And over here again YKJ 0000, accept, and in the last image, so YKJ 0000, accept, and it's done in all the 4 images. I can blink it and I can see that it is marked in all the 4 images, right? Similarly, if any other moving object is there, right? So let's say there was another object in this, we have to give designation to that also, right? And then for one particular data, see the object is here, I'll give the name to it also. So first one I've checked, it is moving in a straight line, visible in all the 4 images, right? Next thing that I have to check, for that I have to open its object verification page, right? And as this is a different object from the first one, I'll give it the second name, I'll give it another name, let's say YKT 0001. Again, the format for naming of an object is 3 letters and 4 numbers, right? 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 3 letters and 4 numbers right? The Now I'm getting some queries that whether letters are case sensitive or not. They are not case sensitive, right? So in first image, but make sure whatever you are entering for all four, it should be same. So 0001, second, third one, YKJ 0001, except third, and in the fourth one, again YKJ 0001. So it's done. I have marked my object in all the four images, right? Done. Now a next step is so make sure you mark all the moving objects in the in this. Then our next step is to generate a report, right? Because we are not going to send these astrometric screenshots or anything to IASC. How we are going to report these moving objects? By sending one report to IASC, right? Now what is that report? So that report is called MPC report, right? So how does an MPC report looks like? We have to make an MPC report. Now to make the MPC report, so MPC report somewhat looks like this, right? And how to make this? So your MPC report actually consists of your name, right, and the object lines. So from where you're going to get the format of this? So for this, what you have to do, be on your software Astrometrica, right? Go on the option internet, and first option, send MPC report. Now once you click on the send MPC report, here you can see one report. So from here you cannot directly click on send, right? Because right now this report is incomplete. You have to include few things in it, right? So how to include? First, copy all the report, and everyone, please don't try to use shortcuts here. We'll press Ctrl A. Instead of selecting all, it will start again the astrometric data reduction. So instead of going for shortcuts, right, use the mouse. So copy, and now you have to paste it in a notepad file, nothing else, only notepad, right? No Microsoft Word, no WordPad, nothing, only a notepad file, right? Press it here, right? Now in this report I am going to increase the font size so that you can see. So let's keep it 16, right? Now in this report we have to include our name, right, and the image set, because they are how they will get to how IAC is going to know that which data set we have reported, right? So the first line will remain same, that is CODF 51. The second line of OBS will also remain same, right? The third line is the measurers line, right? So as you are going to analyze the data sets, right, you are going to be the measurers, right? So you have to change this line. Now there's a particular format for this line, right? And the format for this notepad line, let me just open a new notepad over here, right? The format for this line, I'll write it so that you can write it for your reference, right? Let's say my name is Yogesh Kumar Joshi, right? So the format for MEA line, measures line, will be MEA. Instead of writing my full name, I have to use the initials of my first name, right? Y dot, let's say I directly have a surname, so I will press space, then Joshi, right, space, and right, then your partner's name. Let's say my partner is Tarun Sharma, so I'll write over here T dot space Sharma, right? So Yogesh Kumar Joshi, I am going to include my second name as well. Y dot K dot Joshi. So only your surname will be included completely. Rest, first name, middle name, only the initials will be included, right? So may dot K dot Joshi, and right, in between Joshi and there's a space, and after and also there's a space, right? Then Tarun Sharma, T dot space Sharma, right? So institute's name is Space India. So I start from the capitals, right? SPAC space India. Let's say I'm in Delhi, hyphen Delhi, comma, space India, right? So this is the correct format for mentioning your institute's name. Let's say some institute's name is something else. Let's say I take a school, Delhi Public School in case of school's name, right? So after my MEA line, to enter this, I'll open up a bracket, I'll write down, so my school's name is Delhi Public School, let's say Greater Noida, India, right? So how I'll write it down? I'll write it down Delhi Public School. I can use hyphen if I need, and if it is not, if you don't want to use it, you can skip it. Greater Noida, then comma, then space and India, bracket close, right? So this is the correct format for writing a MEA line. So over here I have mentioned space India, hyphen Delhi, comma India. Now anything which is coming before the comma is your institute's name. So make sure the institute's name that you have mentioned in your media policies or in your documents or while doing registration, the name is same. And after the comma, if you'll mention anything, that will be considered as country's name, right? So be very careful while writing this MEA line, right? So MEA line for Yogesh Kumar Joshi, Y dot K dot space Joshi, right? So this space Joshi, then again space and space T for Tarun Sharma, T dot space Sharma, space for my institute's name, open a bracket, space India hyphen Delhi, comma, country's name India, right? Next thing, the next line will remain unchanged. This is the specification of the telescope. Next, here you will be getting a net ppm XL line. After this, you have to insert one more line. Now this line will tell IAASC that which image set you have analyzed. So the line is image set. See, I of image is capital, set of S of set is capital, colon. No other symbol other than colon will be accepted, right? So without any space, put the colon, right? And after the colon, put one space and put the name of your data set. So to be on the safer side, how you're going to put the name of the data set, go in the same folder, right? And copy the name and paste it over here, right? Okay, I hope till now it's clear to everyone. Okay, so if we are, I have got a query. If we are from separate institute, what should be the format? So then you have to write the name of only one institute, right? both my partner and I finished 12th and are not in any school, what should we put there? So put your school's name over there, right? Or put the name of yes, put your school's name or the last institute's name which you have attended, right? And then you can do it here. Apart from that, any other thing which I'm getting over here? Okay, so I hope till now the queries like you are we are done with this report making. Right now here the remaining lines are actually the data lines, right? So here you can see YKJ00. So there are 4 data lines for one object. If you remember that we have designated one object with YKJ0000, and the second object also we are having 4 data lines. So in your report there should be at least 3 data lines for a moving object. Right now, next thing is to send this report. So for this we are going to save this, right? So I'll click on file, save, and where I'm going to save it, let's say I save it on the desktop. Now what should be the name of this? The name of your report should be same as the name of data set, right? Anything else apart from this will not be accepted, right? I repeat, the name of your dataset report should be the same as the name of your dataset, right? So the dataset name.txt file, save. So I'll save it on the desktop, and then my next work is to email this thing, right? Email the same report to IASC. So where I'm going to send that report, right? So here are the email IDs. You have to send the dataset report to IASC, search@hsutx.edu, and you have to keep AIASC team in CC. Remember everyone that you cannot skip AIASC, right? In every communication you have to keep AIASC in loop, right? Second thing, while sending the reports, right? So report has to be created in notepad file. I hope that is clear, not in any other Word document. Think save the report in the name of image data set. Third, only one report should be generated for a particular data set, right? Fourth, for the maximum chances of discovery, report should be sent within few hours of, like, let's say you get the data set, right? Or let's say you even let's say you're busy and you're not getting time to do it, right? So take 2 or 3 days, right? And even after that, if you don't get the time, right, you can send the reports later, but it will reduce your chances of discovery, right? So try to report the moving objects as fast as you can. Right now there can be one common question: in case there is no moving object in your data set, right? Then what you are going to do, how you are going to generate the report? So for this we are again moving back to this astrometric software, right? I'll open it again. Okay, so I'm getting one query that do people get the same data set or the different one? So each one of you will be getting a different data set, right? So all the data sets are different. Now I'm going to take one file. So let's open these 4 images and let's make a report when there as no moving object. So let's say for this first step is astrometric data reduction, that is mandatory. Okay, so data reduction is done. Next step, you can check for known moving objects overlay. Now, next, blinking, and the blinking has started. So let's say there's no moving object. So in that case, if you just click on internet and you will send MPC report, you will not find anything here. So how to generate the report for this, right? So in this case, what you're going to do, take any random object, right, and just give it a designation. The format for designation will remain same. Let's say I give it YKJ 0002, except, and once you give it any random object a name, what you have to do is next step, go on internet, send MPC report, and you'll find that an MPC report has been generated, right? Copy all the content. As you know, there is no moving object in this, right? So what you'll do, you'll open your notepad, paste your content here, right? Change these MEA lines. I'm again going to take the same names, Yogesh Kumar Joshi, and space T dot Sharma, again your institute's name, space India, say Delhi, comma India, country's name, right? Again, next thing that I have to change is net ppm to insert this image set line, image set I and S of image and set as capital, colon, space, and the name of this data set. So for this, so let's say this 201 was my data set. Copy, paste, and I have to remove this line because this was just a random object that I have marked. And here, as I have not got any moving object, I'll write down no moving objects detected, full stop, right? So no moving objects detected. Remember these 4 words if you're not getting any object, right? Nothing other than this. Let's say no moving objects found, or let's say there's no moving object, anything. If you write anything apart from this line, no moving objects detected, your report will not, right? So write down this line, no moving objects detected, save your file with a name as a name of your data set, and email it, right? So where you have to email it, right? As I told you, you have to email it to IASC, right? Just write down this email ID, everyone, IASC search @hsutx.edu, and you have to keep AIASC space -india.com in CC. Now, while sending the email, what you have to do is your subject line, the format of subject line should be this only, that is MPC report, then your dataset's name, byte, then your institute's or school's name, right? I repeat again, the subject of email body should be this only, MPC report, word MPC report, then dataset's name, then by your institute's name, and send your file as an attachment. So if I have to show you the procedure, uh, go on my email ID. I'll compose a new mail. So for this over here, I have to search to IASC search @hsutx.edu, right? Then in CC, I have to write down AIASC @ space -india.com. The subject line should be MPC report. Again, name of my data set by my institute's name, that is space India, Delhi. That's all. And remember one thing, your email body should be empty, right? So even if your signatures are there, right, just remove them and attach your file. So from the desktop, you take your file. So here's my file 201, and I open and send it, right? So right now I'm not going to send it as it is a practice dataset report, right? So all the practice dataset reports, you are going to send it to AIASC only, right? You're only going to send the reports of the actual datasets to IASC. I hope I am clear. I'm going to repeat it again, that the practice datasets report you are going to send to AIASC, right? And I advise you to send them before the phase starts, right? So that you can have some practice on this software Astrometrica, right? So report that you have sent, right? Next, AIC flow step. So I am going to give you a quick revision of all the steps, right? Because I have got one query that they have missed some step, right? So I'm going to give you a quick revision of steps, right? First thing, you have to download the data from your school folder, right? How you're going to do it? By going on this link on the space website, right? space-india.com. There you have to go under the section of outreach, right? And in that section of outreach, you will find, let's say if I go space-india.com and go in the section what we offer, outreach, associated member program, and all India Asteroid Search campaign. And on this page, if you scroll down, you'll get data sets, right? So in this data set, your school name, your institute name will be reflected. Let me be very clear that right now it is not, they have not been updated because phase has not started yet, right? So your school name will be here. You'll click on this and you'll be redirected to a page of IASC, right? There it will ask you for some username and password, right? And the username and password they will share with you, right, before the phase starts. Then your next step in this will be astrometrica installation, right? Install the setup, update the MPC database, right? Set the configuration to PS1, change the star catalog, right? Then load your data, all the 4 images, right? Then first step that you have to do is you have to take care of 3 steps. First is astrometric data reduction, then known objects overlay, and third one you have to blink the 4 images, right? Now when you are blinking them, if you find any moving object, click on it, give it a designation, right? And then generate a report. Right now, while checking for the objects, you have to take care of 5 things. One, your object is moving in straight line. Second, it should be visible in at least 3 images out of 4. Third is SNR value should be more than 5. Fourth, its magnitude should not fluctuate by the value of 1. And fifth is its Gaussian curve, that all the data points should lie on the Gaussian curve, right? Then make it copy its report, put it in the notepad, right? Edit the report. What you have to change over there, one is the measurer's line with your name and institute's name. Second is the image set line, right, that you have to insert. Third, if moving objects are not there, then you have to include no moving objects line, right? So edit your report and then you have to send your report, mail it as an attachment to IASC search at the rate hsutx.edu, and keep AIASC in CC. For practice data sets, you are only going to send it to AIASC. Remember, for practice data set, you are only going to send the report to AIASC, right? Then your subject line for the mail should be MPC report, your dataset name by your institute's name. No other subject line will be accepted, right? Next, what you have to do now. So first, you'll install the astrometric software, practice sample data sets, send it to our AISC email ID, right? And one thing, check your email IDs listed with us is correct during the registration. You can join our Facebook group, right? That is space AISC. And if you have any queries, right? So any queries you can mail us on aiasc@space-india.com. And for any technical support and help, so 3 contact numbers on your screen are there. You can write them and you can call these 3 members from the technical support team. So whatever help that will be requiring, we are there to help you out, right? So one more thing, the media policy, right? As I told you, space should be in the loop of every communication between you and between the media, if you are interacting with the media, right? And space name should be mentioned with AISC, right? So good luck, happy hunting, and I hope you all get a discovery. So with this, I would like to sign off, right? Happy hunting and be a discoverer. Bye bye. And yes, you can put all your doubts in the comment section. I'll revert them one by one, right? Or okay, bye.